Okay, so in this class, uh, we're going to talk about the ellipse a little, and then we'll talk a little about the hyperbola. Now, I'm not going to go back what you should have covered in the previous course, which involves an introduction to these two conic sections, right? The ellipse and the hyperbola. You should have gone through things like the definition that you're looking at here. Uh, I still have it in the notes here. I think I sent these notes to you already. I'm not gonna go through back all of those, the definition and properties of it and all of that. No, but you can read this. You can read this. You can supplement your reading with a bit of research on the subject. And there's so many resources online that you can look at. You want simple explanations. You have all these AI tools. You also have YouTube, and so that can bring you back, or take you through the basics, right? Um, this is talking about all the you know, the bits and pieces of the ellipse, the focus and the endpoints and so on, their relationships. And I think eventually you had to, you dealt with this in the previous course, right? This is, let's see if I can make it a little bigger. Yeah. Uh, I'm hoping that this is clear enough for you, right? You're seeing the various parts there, depending on how the ellipse is oriented. What you're gonna see, I mean, what you're seeing here is the ellipse being centered at the origin, right? So there's no translation of axis, which we really have to deal with in this course, right? But this is what you had dealt with in the previous course. An ellipse centered at the origin, and the orientation is a little different, right? One is oriented on the x-axis, right? The major axis being there, and one is the major axis being on the y-axis, right? These are, well, to be honest, I don't know why I mean, you're having two equations here, right? You need not memorize two equations. It depends on the size of A and B, right? Um, that will basically tell you where it's oriented. And you're supposed to figure that out by now, right? You didn't have to memorize two sets of equations. You would know based on the magnitude of A and B, oh, and this thing is oriented on the y-axis or the x-axis based on the sizes of those. Which one is bigger than which one, right? I'll leave that for you to, revise and figure out, right? So this is what you dealt with in the last course, right? Ellipses that are centered um, at the origin. Good. So what we're going to focus on in this part of the, well, these are examples and so, right? You can go through back these, as I said, these are not really my concern. Um, you were supposed to deal with that before. This is my concern here, right? Where the ellipse is not centered at the origin, but instead it's centered at the point HK, right? And again, there might be no need for us to, you know, worry ourselves about, memorizing two sets of equations, right? It really depends on the size of A and B, and you could have figured that out without switching around. Notice the first one you have A square, and the next one you have B square. The next one you have B square in front, right? But you need not have that, right? You can actually know from the size of A and B where uh, the major axis is, right? But well, all right, you want to memorize two equations, but you don't have to memorize anything. So you can write this down somewhere in your little, what you call it, your formula sheet, right? So you need to know these two equations. and be familiar with the form, right? What A will tell you, what B will tell you. Well, the H key, you know that's the center, right? So you're not having a center, the origin now, no. You're not having the center, the origin. You're having the center H key. So well, you'll see one in just a moment, an example, right? Um, A and B, uh, well, you will figure out from the size of A and B whether it's oriented on the x-axis as the major axis or the y-axis as the major axis, right? As you do many of these, you should already be able to pick that out, right? And then I think there's a relationship between A, B, and C mentioned before. That doesn't change, right? That you can now figure out where the focus is, right? I say foci because there are two of them, right? So you can actually know where the two foci are based on that relationship. So keep this in mind. This is our main, um, well, it's two equations. As I said, you don't need two, you need one, right? Um, Based on the size of A and B, you can know um, the orientation of the ellipse, right? So that's the general thing there, right? Uh, so let's look at an example. Okay, look at this one. So you want to show that this curve uh, is an ellipse, right? And they're asking you to sketch it. And notice they mentioned the location of the foci, right? Meaning you have to get that C value somehow clear about it. Good. So sometimes you can watch this thing and know that it's an ellipse. Remember we talked about it. There's a plus sign between the x squared and the y squared term, right? And right away when you see that, well, you're thinking, oh, it's like a circle or an ellipse, right? All circles are ellipses, right? Yeah. But the fact that this is 16 here and that's 9 there tells you no, you're not dealing with a circle, right? All those are telling details, right? Good. So right away you don't suspect this is an ellipse, right? But you want to get more details because to sketch it, you need to know, well, what are the vortices, the co-vortices, and I think they want the foci as well, right? The two of them. Um, so what are we going to do? We're going to take this equation and complete the square for the terms that got x in it and the terms that got y in it and so, right? So I'm not going to, well, that's for your, you check the algebra, so, right? Do some completing the square business. So, right, and you end up with that, they say, well, divide through by 144, and you end up with this here, right? So lots of telling details there, right? Right? Because the 16 is bigger than the 9, well, you don't know, oh, this thing is oriented parallel to the y-axis, But so you're looking at that. We got the center already, right? 2, 3, that's not hard. What is it you want? Um, mhm. A is 4, so the major axis of x is 4 units, right? So all you got to do now is you know the center. At 4, you get this vortex here. Minus 4, you get this other vortex here, right? Uh, then you take the 9 and you divide it now, you square root it 3. So the co-vortices will be 2 plus that 3, you give you the 5, and then minus the 3, you get a minus 1 here, So you can know the vortices, co-vortices, and to get the foci, well, you have to use that C relation, the relationship connecting A, B, and C. Find C, right? And C is root 7, right? So now that you have C, well, you can get the foci because it's going to be, you're going from here, you're adding uh, root 7, right? So it's just, that remains the same, 2. The x coordinate is still 2. And the y coordinate is just 3 plus the root 7. And down here, it's going to be, well, same 2, x coordinate still the same 2. And the y coordinate will be 3 minus the root 7. Right? So you got all the details there. What else you want? And you sketch the thing. Right? What can happen? You can be given, you can be given, I mean, in this one, you had the equation, right? You had the equation, and you have to now get the graph, right? You have to get a graph and put in all those details. I can very well ask you the very opposite. I can give you the graph, and I might not put in all these details and tell you, well, look, write down what the ellipse is. I hope the rain is not going. The rain starting also. It might want to disrupt my recording here. Okay, yeah. So you can very well be given the graph, and then you have to come up with the equation, or I can ask you anything about the ellipse, right? The possibilities are a whole lot, right? So it's good for you to familiarize yourself with some different ways the question can be asked about ellipses, right? I might have to, I wonder if I have to pause here with this one. I'll pause a little before I go on to the hyperbola, right? And I think that's all an ellipses, right? These are some questions, and I would think that you have AI to help you with all of this, right? You just type in any one of these into AI and it will do the question for you. You just now have to make sense of the solution. So, yeah. So you can try some of them. What if I had answers at the end of this? You don't need me to give you the answer. As I said, you have the AI, right? Let me pause the recording for the sake of this rain. It looks like it's easing up a little. Yeah, so make use of your AI and so on. You could solve any one of these, right? You could always, uh, yeah, look more questions. Right? Some of them are tougher as you go on, right? Let me pause because I'm not certain what this rain will do for. Not the rain has stopped. Yeah, we want to turn our attention now to the hyperbola. Again, you had covered this, or you should have covered this in some detail in the previous course, right? The definition, the equation when it's centered at the origin again, right? So again, in the notes that I sent you, you should have all of this. You can always go it over back, um, get the finer things, these storms and so that I'm talking about. Go back through them, and so right, and the little derivation of the equations, right? So here, uh, the notes I sent you, one of them is much clearer. I think that's a PDF. These notes I did many years ago, and I scanned. I think I scanned there. I think I didn't scan. I had a document camera. Usually had one shown. I have it right there in my bookstore here. It's right next to me. A document camera, and I just took pictures of all the pages and put them together. Yeah, so these are basically the the equations, right? When the center is the origin, right? So this is more of the previous course. Oh, by the way, now that I can't ask you anything related to what was in the previous course. I can, because this is course is just a follow-up to that. You can understand the more advanced things and more, newer things unless you understand this, right? So don't think I can't ask you something related to one of these uh, conic sections that are centered at the origin. Don't think so. I could ask you anything. Yeah, and you can go back through these examples. They're a good revision for you, What we're concerned with is yeah, we're concerned with these two, right? And that's when you have a shift now, right? There's a translation of the center now, and it's at HK and not at the origin, right? And these are the two equations that you need to concern yourself with, right? Actually, is the equation that holds when the hyperbola has a center of HK, right? So again, you don't have to memorize them, but you have them in your formula sheet. Working with them over and over, they become second nature to you, right? Well, you see the difference really between the ellipse and the hyperbola. There's a minus here instead of a plus, right? That's basically the difference in the equation, right? Let's maybe look at a single example, right? So you want to know that, well, okay, show that this curve is a hyperbola, and these are telling details. As soon as you see a minus sign there, you don't know. You're dealing with a hyperbola, minus sign between the square terms, right? The x squared and the y squared is a minus, so you already know there that you're dealing with a hyperbola. So I want you to sketch it, so you have to do a little bit of analysis, right? To get some more details, right? So if you want to know, they're asking for the foci, the vortices, they want the asymptotes, right? So all of that they want. So what do we do with it? Again, we do our little bit of completing the square. That's what you see happening here. And you bring it in this form, right? And in this case, you note that these two numbers are basically the same, right? So what do you have? Well, you got your HK there, right? H and K, 2 and 4. How do you know that the focal axis is the x-axis? Well, this is in front, right? You have that in front, right? So it doesn't really have to do with the size of these, but I think it's which one is in front, right? Yeah. So you got that. The C value, well, you get it from this relationship here. We have an ugly number, right? And what else is there? You got that, you got that. You got A, B, C. So the vortices are going to be 3 units left and 3 units right to the center. Well, you know all of that, right? And they actually tell you the point, right? Because you know the center is 2, 2, 4. Yeah. It's going to throw all of this in a diagram. Throw it on a diagram so that you can, you can quickly put in the point, and then you can actually get your foci. Let's go to the diagram just to illustrate that, right? So we got our center to be the 2, 4, right? Foci, you just have to add the C value and then subtract the C value to go this way and that way, right? And the other problem after that, Um, I think you want the what? The asymptote. So the asymptote, you put equation equals 0, and you basically you get rid of all the nines and you solve, right? So you add this, and that will give you the asymptotes to be y equal x plus 2 and y equal minus x plus 6, right? And those are the two asymptotes here. It so happens that because the coefficient of x and y was the same, this is basically what I call it's an equilateral hyperbola. Why they said that is that if you were to like form this into a nice square here, right down here, vortices come down to meet the asymptote, go across, come back through here. You will end up with a nice square. Right? I think there's a more of the idea. That is, they call it an equilateral hyperbola, and that the asymptotes are going to be perpendicular, right? Like in a square, right? Because a square is a rhombus, right? And rhombus is the diagonals intersected right angles, right? Yeah. So go through back the example and see how you can figure out that you got the center that wasn't so hard. You got the vortices, which are this one and this one here, based on the numbers you found, right? Centers of these and this vortices, you just have to use A equal 3, go left and right, and you'll get the vortices. And then you take those two and you will add or subtract 3 and root 2, right? I think that is, you will take it, add it to the center, right? Center to get that. Yeah. And that will give you your two foci, right? That's the two here. You'll take some figuring out. You look at the arithmetic, you see you get this here, right? You can always throw that on one of these graphing programs, GeoGebra, or my favorite is Desmos. And you're going to get a nice sketch of the, not a sketch, that's a computer generated image. It's going to really be really nice, right? But I'm going to go into not anything more here. I'm going to pause there, because you want to go into uh, something called rotated axis. Let me pause a little and get that file open. I will get into that. Good. So here we are now. We want to deal with rotated axes. So in the notes I sent you, you will see a little bit of a rehash of the equations that we dealt with, where the center is either the origin or it's translated, right? But the the major axes are either parallel to the x-axis or the y-axis, right? Always that. So that's these equations here. These equations here. All right. So you're having this is the a little tricky circle here, right? The hyperbola, the ellipse, then sorry, this is the parabola. Sorry, parabola, ellipse, and then the hyperbola, right? So that there is that's a rehash of it. And you will figure out that when we take these here and we get rid of all the fraction looking expressions in the or terms in the equation, you can actually write this. You can actually write this looking like this here, right? You can actually write it in that form. The examples we did earlier did look like that, right? Right. Yeah, at times you have a minus sign here. right? Well, that depends on the C value, right? You don't have to have a plus sign here. Yeah, good. So, what about though if you have what you call a rotated axis, meaning the axis of the conic section is not parallel to the x-axis nor the y-axis. And things get really, really, especially the algebra, gets very, very complex, right? Let's skip over this here. I want to get straight to that, right? Look at this one. This is an example of a rotated um, conic section, right? It's an ellipse. So where am I? Oh, I jumped over too much, right? So look here. If you have an equation of this form, look at this. You notice a bxy, well, not a b, the xy term. Whenever you see you have an xy term, well, know that you don't have a conic section now that um, is is parallel to the x or y axis. You might have some degree of rotation happening, right? And therefore, you have to be aware now. Things are not going to be that simple, right? And they quickly took this one and they sketched it here. So you see a situation where the major axis is through here, right? Through here, so, right? There's some kind of rotation, right? This is a clockwise rotation, some degree. Did they tell you? They didn't tell you. We'll get the way of finding the angle in just a moment. Let's investigate this rotation of axes a little, right? So here you have a point, right? And if you have an axis now we know the normal x and y axis, right? But now if the axis is rotated somewhat by theta degrees, that's what you see in theta degrees, right? And your new axis now becomes x prime, as you see here. I'm just writing it big, and y prime, right? What we want to do now is find some relationship between x, right, and x prime and y prime and so. So you'll see your trigonometry coming. If you analyze this here now, they're telling you that x is going to be equal to r at the length of this line segment times times cos of theta plus alpha, right? So that's this angle and this angle. You all did resolution. You all did resolution of vectors. Maybe you did a physics course on resolution. So if you resolve this down, this x value here is going to be this. And if you resolve it this way, that y value is going to be r sine of theta plus alpha, right? Because if you have a vector going this way, so a vector, let's call it p, and you have some angle here, right? Let's call it beta. I don't want to use alpha or theta. Call it beta. Then the vector here is going to be p cos beta. And the vector up here, okay, the vector up here is going to be p sine beta, right? It's the same thing they're doing here, right? You don't have to know this. You can actually use your basic trigonometry and know that that's true, right? Analyze it and you'll see. But let me erase all this marking that they'll be left with. So we got a little relationship there between x, the length of the line segment, and the angles and so, right? But so now from that, we can see that x prime is going to be r cos theta only, right? So if you take this point P and resolve it down here to get y prime, sorry, X prime, that is, right? It's going to be R cos alpha. And if you were to resolve it this way, right, and get Y prime, is going to be R sine alpha, right? So there, we were seeing some kind of relationship between X and X prime, Y and Y prime. That's the connection we want to make, right? So if we take this first expression here and the second expression, expand it out, that's what we'll get. We'll get those two, right? And we actually notice down here has R cos alpha, right? If we take X prime and put it where we see R cos alpha, and we put Y prime in the place of R sine alpha in this expression here, we're going to get it. And what we basically have here now is what they call the rotation equation, right? Basic thing is that you're seeing a relationship between X and X prime, right? Well, we're seeing X and X prime and Y prime, and then Y and X prime and Y prime. There's a relationship there, right? So you can actually use the equations. I'm not saying it's going to be easy, but there is a relationship, complex relationship that is. But nevertheless, the algebra is available, very complex though, to change from one to the other, right? Convert from one to the other. But it's doable, hard but doable. With AI, well, everything is no more no longer complex, right? So let's see some situations here. I might need give me a second. I think I have to write down myself. Let me just write down the relationship. X prime cos theta. Because I'm gonna go away a little from the page. All right, good. So we're having an example here, all right? I should make this a little bigger here. So they're saying that, okay, you have the axes, the XY coordinate axis that we are familiar with, and you rotate it through an angle of 45 degrees to obtain another coordinate axis, X prime, Y prime. Find the equation of the curve, X squared minus XY plus Y squared minus 6 equals 0. So this here is the rotated conic already because there's an XY term inside, right? What we want to know is, well, basically what equation is it? You know, is it an ellipse? How is it oriented? We want, more details of it. So what we'll do, we know that the angle is 45 degrees, so we'll need to get sine theta and cos theta. So that's what it is. Sine theta is 1 over root 2. They didn't rationalize the denominator. And cos 45 is 1. Oh, they're both there. They're both the same thing, right? You take these two numbers now and you put it, that's this equation. You put it in the place where cos theta, sine theta, cos theta. You put those there. So the relationship becomes this, right? So you have X is this ugly thing. Y is this ugly thing. You take these two now and you put it where you see X and where you see Y, right? You put where you see X, you put this, where you see Y, you put that. And this simple, simple equation becomes this very, very complex thing. And I want you to, in your own free time, expand this out, right? It's really going to test your algebra, right? It's going to really test your algebra. You expand it out and simplify, and you should get this right? This here. This is really going to put your brain to work, right? You're going to get this, and when you get this, that should simplify to this here. So basically, this here is it's an ellipse. You recognize it's an ellipse. And it's basically it's parallel to the x prime um, coordinate axis, right? So let's try it. Yes. Yes. So it's a 45-degree clockwise rotation, right? A clockwise rotation. So they're rotated 45 degrees this way. No, that's wrong. The anti-clockwise rotation of 45 degrees. Yeah. The anti-clockwise rotation of 45 degrees. Because originally it was like an ellipse that was oriented on the x-axis, right? It was this way. Let me just draw it here. It was this way, right? And then you rotated that way 45 degrees. Pardon my horrible drawing. It's there, right? So you had that, and you actually did a rotation that way, right? So it's really this graph. You can actually draw this and rotate it 45 degrees. Oh, there are some programs that can do this for you, right? I'm trying to remember. GeoGebra, I think, can do that for us. GeoGebra can actually do this. Right? There you have that. Right? So it's basically, if you can draw this, right? Forget the prime and the prime base. Draw this on the the XY coordinate system and rotate it 45 degrees. Like you take what? You take what? You take these points. So this point here would have been somewhere here, right? You don't have to do every point. So this point would have been here. This point would have been here. This point would have been here, right? And this point would have been there, right? So you understand? So all you're doing is you take this thing and just rotate it 45 degrees. You can actually do that with a protractor, and rotate it, and you will get all the points. Protractor compasses, right? Don't forget that. If you remember your little bit of what is it? Geometric construction, right? That's part of the CXC syllabus. Yeah, you can do that, but there's software. GeoGebra does this for you, right? You can actually rotate the Conic. I wonder if I can pause and see if I can. Yeah, let me pause, and I just want to. I want to see if I can quickly find the software. Let me see if I can do that. Okay, let's look here. This is GeoGebra, and they're giving you an example, right? So, and you can change it, right? You can change it to anything. You can change what the values of A, B, C, D, E, F. You can change anything, right? This is a general form of the equation, right? So you can change A, B, C, D, E, F. You could change it to suit yourself. That will give you any conic section in this whole wide world, right? And of course, if you want it to be in the form of the rotated conic, you put in the XY, right? You put in the XY, right? Good. So this one here, what was the one we were doing? All right, let me use this as an example. I'll go back to that one. And you see this little thing here? You will actually rotate the thing for you. Look here, look here. Look here, look here, look here, look here. Right? To get it back, you can actually know then that, you know what? Thing went through, what is that, 63 point something degrees. This green is really like a clockwise rotation. I should say the green is an anti-clockwise of this blue, right? And well, they have some horrible numbers here. They have some horrible numbers there, and they don't have it in the form that you want it. Something over x squared and something over y squared equal 1. They don't have it like that. I guess you might have to use another software, right, to convert it. Let's try the one we had. Let's see, what's the one we had in the example just x squared. Let me just xy plus y squared minus 6 equals 0, and simplifies to x prime over 12 plus y prime squared over 4 equal 1. Let's just see how that behaves. Good. So we're back here, and I want to change. All right, good. So A is equal to 1. B is equals to minus 1. C is equals to 1 as well. 1, share 1. D, you have no x term. You have no y term. No x term, no y term. So this F is minus 6. Oh my, yes. So that's it there, right? So that's it. And you can see all, yeah, you can see that. And then when you want to know, well, what's the original equation? So this is the equation we had, right? That's what we had. And you just take this now. What's going on? Let me make it bigger. Yeah. Go back to it. That's what we had originally, right? So if you want to know, well, what equation was it, right? What equation was it? Take this and you take it on, take it on, take it on, take it on. Yeah. Right? I notice it's not going to the full. Why are we getting 43.8 degrees? You see what's happening here? Because, yeah. If I cannot change the. You're not getting the full 45 degrees. You're getting 43.8. It's supposed to be 45 degrees. Something wrong here. Does it look like it rotated too much? My eyes must be dazzling. You're supposed to get phi equal to it's supposed to be 45 degrees. Right? It's not, we're not getting 40, we're getting 43. I notice it's not going beyond that. It's supposed to go to 45 degrees to get back. And somehow this doesn't look to me. Oh yeah, you see what? It hasn't rotated fully. It has to go some more. But somehow the program isn't allowing it to go full. Right? Right now it's at 43 degrees, 43.8, it has to go to 45. The program needs some development for some reason. Right? Because you can't use this now. Remember, it still has an XY term because you have to rotate it to the point where this XY term disappears. Right? You have to rotate it to the point where this XY term disappears. So this program definitely need, or maybe I need to, or we need to, what if I could step this? Angles shall be able to step. I wonder why they have it like this. I'm seeing as a hand there. I wonder if I could have changed it. For some reason. All right, all right. But you got the idea. The program can do some rotation, but it's not, it needs to take it right down to the x-axis here and right across to the y-axis. And what that should have given you, this angle is supposed to be 45 degrees, and then that will make this xy term disappear completely. And based on this number and this number, you can now quickly know which ellipse it is, right? That is how it's supposed to be. So, I search for another program, continue. You must search for one. See what that. All right, go back to the problem here. So I'm back here. Yeah, you got it here. So let's look at another one. In this one, you're just translating you're rotating a point, 2, 4, right? You're just rotating a point, 2, 4. And you're rotating it through an angle of 30 degrees. Right? And I guess when they say 30, you know you're doing an anti-clockwise of 30 degrees, right? So you find cos theta, cos 30, sine 30, and you put it inside the translation equation now, right? And it will actually translate. I shouldn't say translation equation, the rotation equation. And you will get now, this will be the x prime coordinate, that will be the y prime coordinate, right? You just have to remember the relationship, right? You have to remember the relationship between x prime and x and y prime and y. But I think it's y and x, both of them is inside, right? If you go back, okay. You have x and y inside here, and x and y inside here, right? So you have to remember that to do this. Good. So what we're gonna do now, we're gonna switch over to doing a little analysis of this general equation of, as a matter of fact, all conics, right? All that needs to happen when you're dealing with a conic that is parallel to the x and y axis is that b is going to be 0. If b is 0, meaning there's no xy term, you right away know that, oh, you have something, you have a conic section, right? That is oriented parallel to the x-axis or parallel to the y-axis. The minute an xy term comes into play, well, you don't know that you have some kind of rotation, right? And in order for you to got to do that complex calculation that was you see earlier, right away you want to know, well, sorry, how you expect us to do something like that in the test? I will not do that to you, right? But there's an easier way to figure out, well, all right, what's the angle of rotation, right? What's the angle of rotation? Well, you can use this formula here. Cos 2 theta, where theta is the angle of rotation, is equals to A minus C over B. So once you can pick out A, you can pick out B, you can pick out C, or D, E, and F. You can actually figure out, right, the rotation of the conic section. You can actually do that, right? So there you have it. Very simple approach you have there, right? Maybe an example will do the job. So you say identify and sketch the curve xy equal 1, right? So you pick out what A, what B, what C, and so. And what do you get? You get cot 2 theta equal to 0, right? And they're telling you that, okay, this is going to be true if 2 theta is pi over 2, which means that theta is pi over 4, which is 45 degrees. You substitute that now, well, you know, cos theta, sin theta of 45 degrees are going to be 1 over root 2, 1 over root 2. Put that in here, right? And when you get that now, and you do the transformation, right? You will get this here, right? When you put it inside here, in xy, you will get this here, right? Which simplifies to this. And again, the mathematics here is quite complex, right? You can try it on your own and you will get this, right? So this is an equation of this form. And you can actually pick out, well, the center, the vortices, uh, foci, everything, right? That's what they got. They went through all here. Well, you're supposed to know xy equal 1 is which conic, which hyperbola. Y'all supposed to know that. Y'all know the hyperbola y equal 1 over x. That's what this is. It doesn't look complicated, right? But you go through the whole procedure and they're showing you how to get all the values, right? They're showing you how to get the foci, to get the vortices, the asymptote if need be, right? And you're actually seeing the asymptote is the x-axis, right? The x prime axis, right? You'll see when you put in the numbers inside all of it, you get them. And when you bring it down here now and you sketch the graph, you're going to get this here. You're going to get this, right? And this is a familiar hyperbola to all of us. It's that hyperbola y equal 1 over x, right? They just fancy it up to make it look complicated in this example. Right? So that formula is very, very valuable. Right? And here's another way you can get sin theta and cos theta very easily using these two identities, which I think you had to prove when you were doing the trigonometry part of the course. Right? So let's say you know cos theta, right? And that's a trouble to figure out sin theta, cos theta. That's hard. Well, this is an easy way to get sin theta, cos theta. Let's look at another one. They give you one here. Identify and sketch this curve. Horrible looking, horrible. There is an XY term right away, you know that, yes, there is we're dealing with a rotated conic. Right? So what's the angle of rotation? We use this relationship. Cos 2 theta equal A minus C over B. Put in the numbers there, you get this, right? So theta is somewhere between theta 0 and pi over 2, right? So we're going to use relationship. Well, we're using this little triangle here. You're getting cos 2 theta, from which you can get cos theta, right? And you can get sin theta from this relationship. These are two identities that are quotable, right? It's just to quickly get the answer there, you know, because you need sin theta, you need cos theta, right? So you want the easiest way out. So knowing cos 2 theta, you put it on the little one, a little triangle here, a right angle triangle. Get cos 2 theta. And from that, you can get cos theta and sin theta using these two relationships here, right? These two identities. That's what they're trying to kind of fast track getting cos theta and sin theta because you need it. You need it for your subsequent calculation. Knowing cos theta and sin theta now, you put it in the rotation equation. X is this, y is that, and you're taking this now, taking this, and you're putting it in this equation. Why that complication? The algebra is, what's the algebra here? Right? And well, don't ask me to do the algebra. This simplifies to this here. Further, you can you divide through maybe by 25, and you get this here, which when you rearrange it gives you this, right? And now you can figure out, oh, this is an ellipse, and it's as though it was oriented towards the x-axis, and it was rotated by, did we get the angle? So you can calculate the angle, right? Because you got sin theta and cos theta, so you can know the angle, right? And from that, you can actually pick the point, the center being 1, 0. You could know the vortices, the co-vortices, where they are, you know? You could know all of that. But they didn't go into it. They just want a sketch of it. Just the orientation of it roughly, right? Put the center there. If you can actually sketch what? If you take out this x bar and y bar, take it out. Sketch that graph where you have x minus 1 square over 9 plus y square equal 1. And then you rotate it by, I don't know if you can find the angle, find theta. Cos inverse of 3 over 5. I don't have a scientific calculator. Cos inverse of 3 over 5 will give you the angle. They give you out in this thing. It didn't actually tell you. You find cos inverse of 3 over 5 or sine inverse of 4 over 5, you'll get the angle, right? Once you get the angle now, it's like you take that, it's like you will have something like this. You will have a, I shouldn't remember. You'll have a, I have somewhere here. And you rotate it that way, and you will get this one. Right? You get that. And if all of you all know rotation and so, right? You all did rotation in high school. So if you know the vortex here, you can know that. If the co-vortex was here, you will know that there. You know, if you know this, you will know that, right? And if you know this, you will know this because you know rotation, you can actually take matrices and quickly rotate the whole thing, right? Go revise your rotation matrix, right? So this is an anti-clockwise of theta degree. And you will figure out cos inverse of 3/5 or sine inverse of 4/5 will tell you the angle. You can know it, right? That's an alternative way of getting this graph if you don't have a software. Good. So let's just a little bit on the discriminant for a conic section. Right? Just like how you have a discriminant for quadratics. This is just taking it a little further, right? So let's go through this here. So you have the general form here, right? Of a conic section. If B, we said it, there's no B term, right? There's no XY term, sorry. B is 0. Well, you know what you have. You have a conic section that is oriented parallel to one of the axes. Once you get an XY term in there is some kind of rotation. So here they're telling you now that, okay, if B squared minus 4AC is less than 0, you have an ellipse, a circle. It could be a point or something, there's no graph, right? they're further telling you, okay, b squared minus 4ac is greater than 0. It's a hyperbola. It could be a pair of intersecting lines, right? Those are the two possibilities. Then if b squared minus 4ac equals 0, you have a parabola. It could be just a line, a pair of lines, or sometimes no graph, right? And I was telling them that some students in times past, how can you, I mean, let's say you have a situation, right? You have some graph. And let's say you have this 4 situation, b squared minus 4ac is less than. How do you distinguish that it's an ellipse, a circle, a point, or no graph? Right? And you can, well, I have no audience now, but I threw it to them, right? And there are ways you can know besides okay. You're left with a lot of options there. Let's say you try b squared minus 4ac and you get something less than. You can't say, well, I have no other information, but you have common sense. You have some background knowledge. So what you can look at is the value of A and C. And if A and C are different, maybe you suspect an ellipse. If A and C are the same, maybe you have a circle, right? And how do you know that you don't have a point or no graph? Well, you could just try two values for X and Y, right? Try two values. Well, so try a value for X and see if you can get a value for Y, right? Then try another one, right? Try another value for X, try another value for Y. And if you're having several points, if you can get several points, you know that there is some graph, right? If you're having more than one point, you know, well, there are a series of points. And then I just showed you how you can figure out that it's a circle rather than an ellipse, or an ellipse rather than a circle. So you have to do a little further analysis, right? Don't just say, well, sorry, this criminal only tell me this, I can't go further than that. So you have other knowledge, right? And you can now apply. Right? For example, as I said, if you see A and C, it's the same. B, you are very well playing with a circle. If you have A and C being different, maybe you have an ellipse, right? And then you can do some further investigation to show that, well, you don't have a point really, right? Because you probably can have several points here, right? And once you have several points, you have a graph. So you eliminate no graph, you eliminate a point, right? And then you're left with whether it's an ellipse or a circle. And I just talked about how you can figure out whether it's an ellipse or a circle, right? So that extra analysis on your part, you need to do. Right? So I went on to call it the discriminants, you know, again, to tell you some things about the theorem, right? Let's do an example. And to be honest, I can remember many years ago, I gave students this as an assignment. And I remember if to talk about the relationship, you know, how can you tell whether you have an ellipse circle or whatever? And the students, when they presented the first time, you know, something, you don't know something, but you have a gut instinct that the mathematics is wrong, right? You know that. So when they try to bluff me and so on, I said, stop. Something is not wrong. I start to question them. And then they say, you know, sir, we're trying to bluff you out. So start good. So I'll take 2 weeks more. They actually had 2 weeks before. And they spent another 2 weeks, and you wouldn't believe me. They actually came up with where these relationships come up with. B squared minus 4ac less than 0 is going to give you an ellipse circle graph, no graph. They actually came up with why b squared minus 4ac is greater than 0. You have a hyperbola or a pair of lines on your hand. They actually came up with the reasoning why. To be honest, those students submit that thing to me. I don't know where it is. I wanted it. So today I would have made it into a publication, right? I contacted them recently. They lost the thing. Just imagine they uncovered mathematics that is hardly in any textbook, and didn't do anything with it. I laughed the thing too. Uh, one of the girls in the group is actually teaching with her. She doesn't know where she misplaced the thing either. But this thing is worthy of publication. No? Why did, why are we saying this? Why are we saying this? Why are we saying, right? A lot of textbooks don't deal with it. And including this one, and this guy is a world famous writer, right? Howard Anton. Yes. So here it is an example. You want to use the discriminant to identify the graph, right? You have a graph here. So we don't know what it is. Let's say you don't have graph in software. So here you have it, b squared minus 4ac is equal to minus 151. Right away, they're telling you that because it's negative, you either have an ellipse, a point, or no graph. They ask a simple question, why can't the graph be a circle? Why it can't be a circle? I just said it, right? You got 8 here, you got 5 here. The fact that those two numbers are not the same, but you don't know, right? It can be a circle. So you want to suspect more it's an ellipse. I told you, maybe you can try it for yourself. Eliminate the fact that it's not a point or that there's no graph, right? Try some values here, put in some values, see if you can get some points on this thing. And once you know that you have a point, but once you have a point, there is a graph, right? And if you have more than one point, then you definitely have an ellipse, you know? So yeah, you want to do a little extra to the thing. You can try this, right? Don't stop here. You know it can be an ellipse, a point, or no graph. Do the analysis for it to see where you can say conclusively that it's an ellipse, right? Of course, if you're lazy, just type this into a graphic software, right? Like there's more. Yeah. And then you have some nice exercises here that you can take these and if you work out the answer, you're not sure, the AI can help you, right? AI, you have so many AI help that you can get. And you can know whether your answer is right or wrong. Cool. So that concludes all that you have to do on conic sections. I'm going to attach to this. I may attach it at the end of this video, but that might call for some processing and so. I do have a video of a presentation in Borges here on hyperbola. Some of you have absent asked me to record it. So I'm going to send it to you. You can always watch it. And of course, you have all the resources on the internet to do more in-depth research on the conic sections, right? Starting from circles, parabola, ellipses, hyperbola. Right? And that, so your first test, I'm going to put it up, is going to really deal with what did I say? Your first test, your test number 2, and the 2 quizzes that will be embedded in it is going to deal with conic sections and polar curves. Right? So prepare for that next week, Monday at 7 o'clock, because I heard you all got something, some class and all. All right. So we're going to stop there, right?